Guys, and welcome back to another production from CashApp. Today I'm going to show you, or I am showing you, something compound that we can make with the trinitrophenol, or commonly known as picric acid, that I showed you how to make in a previous video. So what we're looking at here is, we have, I think this is about 15 grams of our TNP. And so we have this in a hot solution of about 10% per volume, by volume I should say, ammonium hydroxide solution. Yeah, there's no water in this other than the 90% water that is in the ammonium hydroxide itself. I mean, there's no added water. We have just dissolved our picric acid directly into our ammonium hydroxide. And we are stirring it here, and you can see it has come to a boil. Now we do not want to heat this too much because it will effectively drive off all of the ammonium ions, and we'll be left with just water, and that will do nothing but recrystallize our picric acid for us. So I think that we have, at this point, I can safely say that we have sufficiently heated it and let it react sufficiently. It has been on here heating and coming to a boil for about 10 minutes or so. So I'm going to take it off the heat now and let it cool and crystallize, and I'll show you what this looks like. Okay, so I've taken it off the hot plate. I just have it up on this ring stand to crystallize, and I have put a watch glass on top of it just to prevent evaporation as much as possible. The solubility index here for TNP is pretty low. I would have to look it up to give you the exact numbers for grams of solubility per milliliter. However, it is so low that if we were to try to dissolve this amount in room temperature, which right now, let me see here, would be about 22 degrees C. We could maybe dissolve, maybe a gram or two of this. And I said that we have between 12 and 15 grams. Not exactly sure. I probably should have measured a little bit more carefully. But I just was feeling lazy and I didn't. I just kind of eyeballed it. So I won't be able to give you a specific percent yield on this. That being said, though, you should be able, if you are trying this synthesis at home, to obtain a relatively close to a 100% yield on this. And that is simply because all we are doing is dissolving our TNP in the ammonium hydroxide, heating it up and stirring it, which is allowing the ammonium ion to grab a hold of it, and thus making ammonium trinitrophenolate, and then it just crashes back out of solution. In my case here, since we are slowly cooling it, it will not necessarily crash, it will slowly crystallize, which is what I recommend if you want the nicest, finest crystals. However, the point being that the solubility is so low of picric acid that as this cools, it will roughly 100% of the starting TNP that we put in will come back out as crystals in the solution. The problem with this synthesis is that if you use too much of an excess of the ammonium hydroxide, you can't really boil it down to reduce the volume. And this is simply because when you do that, the ammonia gas will sublime off, if that is the correct term I'm using, a lot faster than the water will, and that is simply because of the density of it and the vaporization temperature, which the ammonium ion likes to turn into its ammonia gas a lot more readily than the water ion likes to turn into water vapor. And if we do that, we are going to essentially just be recrystallizing the TNP and cleaving off all of the ammonium ions from it. And that's great if all you're wanting to do is recrystallize TNP. However, you can do that with hot water. You don't need to use the ammonia. So that being said, keep that in mind. And I will just be patient, let this slowly crystallize out, and I will come back with updates as that starts to happen. Okay, just wanted to update you and show you what this looks like here. We're starting to get crystallization going on. There's a top view of it. You can see all these nice, beautiful, shimmery crystals forming. And if you can see this here, if the camera will allow us to get it, so you can somewhat see that there's still some water vapor coming off. So this tells us that our solution is probably still around 90 degrees C. And you can see we've already got all of this crystal formation here. So that should give you some indication of how insoluble the TNP really is. Again, I said before that I wasn't quite sure of the solubility of this as far as the index goes. And upon looking back on some lab notes I had from about a year ago, I had figured that the solubility of this is around 4 grams or so for every 10 milliliters, and that is of the ammonium hydroxide. So it is going to be a similar solubility in water, but that solubility is at 100 C. As you see here, we cooled down 10 degrees and we are already having crystals just fly out of solution. There's the top view. You can see how many more have just formed in the time that I have been talking to you about this and showing it to you. Just wanted to give you the update, show you guys what was going on. Another thing I should have mentioned to begin with is, if you can see my gloves here, just from getting a little bit of the steam with the vapor of the TNP in it on my gloves, there you can really see it has stained my gloves. So just as with the TNP synthesis, the gloves are very important. It is rather imperative that you wear them for this. You will look like you're part of the cast of The Simpsons if you don't. This stuff unforgivably stains you, and it does not come off. It doesn't matter what kind of solvent you try to use, you will be stuck with it. I made that mistake the first time I made this, of trying to do it without gloves. And as you can see, I mean, I have not even begun to filter this or anything, and you can see the creep of staining that has occurred. So, you can only imagine that all of that would be on my skin right now. If I didn't have these gloves on, you can see that it has stained my lab coat. So, yeah, again, pretty imperative that you wear gloves for this. Not only will this stain everything that it touches, but this does have 3 nitrogen groups in it. Actually, 3 nitronium groups per molecule. And you do not want to be absorbing that into your skin, especially if you have heart problems, because that can result in tachycardia. That could ultimately result in having heart failure, heart attack, high blood pressure, which is your tachycardia. What tachycardia leads to, anyhow. None of these things are good. You can end up potentially dying from any of these conditions, and at the very least you will wind up with a pretty severe headache from absorbing all of the nitronium, and it will absorb through your skin very readily. As an example of this, to treat heart conditions, and this is still widely used in the US, they do prescribe nitroglycerin tabs, so that should be some indication that nitrogen containing compounds are nothing to be messed with. You need to really respect your chemicals that you're working with, especially in this instance. That all being said, we're going to let this crystallize out until we stop seeing the formation of crystals coming, and then we will filter it and see what kind of a yield we get. I did go back and measure too, and I actually used 16 grams of TNP for this, and you can see there's very little, when I tip the beaker, there's very little fluid left in there. So, you know, it is, or I should say that the ratio of TNP to ammonium hydroxide that I used is fairly stoichiometric insofar as solubility is concerned. Another good indication that we have done this properly is that you can see our TNP crystals have now taken on this reddish orange hue, and that lets us know that the ammonium ion has attached itself to the TNP molecules, atoms, whatever, you know, whichever way you want to look at it, it has attached itself. So, you know, when we started out, our TNP was a bright yellow to a sort of orangish yellow, and now we have got more of a reddish orange. So that's all I'm going to say here, and I will come back after the filtration is done. Okay, so here is what we got. I have not weighed it, so I'm not sure what the exact yield is. I'm not really concerned with that. It looks like I got close to 100% yield. And besides all of that, it is still relatively damp, so weighing it at this point would just give me false indications anyhow. But let's do a little proof test here. Okay, so I have just a little bit of it right there, as you can see. I'm going to back the camera off here so that we can get a good view of how this reacts. I'm going to get my trusty sparkulator here. Alright, now mind you, this is still wet, so do not let this be an indication of how this stuff overall reacts. And here we go. Remember, still wet. Okay. Now, that might not look like that is very energetic, but I assure you it is. If I were to take and envelop that in something like a piece of foil, it would not deflagrate. It would literally just explode. But I am not going to demonstrate that because I do not feel like blowing my eardrums out. So with that, that concludes my video on ammonium picric, or dunite as it is commonly called. Thanks for watching.